resolution of vectors, rectangular or Cartesian coordinates. Now let us see the vectors, resolution of vectors in rectangular or Cartesian coordinates. It looks like a rectangle, therefore it is called rectangular coordinates. Now here consider a vector in three-dimensional space. It is in three-dimensional space, vector A vector. So consider A vector in three-dimensional space like this. This A vector in space can be represented by the addition of three mutually perpendicular vectors along three directions. A vector, Ax vector along x-axis, Ay vector along y-axis, Az vector, this is Az vector along z-axis. This is Ax vector along x-axis, Ay vector along y-axis, Az vector along z-axis. Therefore, this vector in space, A vector, can be represented by the addition of three mutually perpendicular vectors along the three directions. Right? So Ax vector is equal to Ax into I cap. Ax vector, Ax is the magnitude of Ax vector. So magnitude of Ax vector. Therefore Ax vector equal to Ax I cap. So this is the Ax vector. Ax vector equal to Ax I cap. Then Ay vector, Ay j cap. This is Ay vector. This is Ay vector along this direction. So Ay is the magnitude of Ay vector. Ay j cap. J cap is the unit vector along y direction. And Az vector equal to Az k cap. K cap is the unit vector along z direction. Right. Therefore, we can write any vector by its magnitude and its unit vector. Therefore, I have written Ax vector equal to Ax I cap. I cap is the unit vector along x direction. Then Ay vector equal to Ay j cap. J cap is the unit vector along y direction. Az vector equal to Az k cap. K cap is the unit vector along z direction. Therefore, the vector in three-dimensional space can be written by the addition of three mutually perpendicular vectors in three directions. So this is the rule. So this system is called Cartesian coordinate or rectangular coordinate system. Therefore, A vector equal to Ax I cap. Instead of Ax vector, I write Ax I cap plus Ay j cap plus Az k cap. Now, here you see alpha. Alpha is the angle between the A vector and x-axis. Alpha equal to angle of A vector with x-axis. Then beta is the angle between A vector and y-axis. Beta equal to angle of A vector with y-axis. Then gamma. This is gamma. Angle of gamma is the here. Angle of this A vector with the z-axis. This is the A vector. This is A vector. Angle of A vector with z-axis is gamma. Angle of A vector with z-axis is gamma. So this is called Cartesian coordinate system or rectangular coordinate system. Now let us see direction cosines. So consider here this is alpha, this is A, consider only the magnitude A, here magnitude AX, cos alpha equal to adjacent by hypotenuse, cos alpha equal to AX by A. Then cos beta, this is beta, cos beta equal to adjacent by hypotenuse, that is AY, this is magnitude is AY by A, magnitude A. Then cos gamma is equal to like this AZ by A. Therefore, cos alpha, cos beta and cos gamma are called direction cosines. These are called direction cosines of A vector. Cos alpha, cos beta and cos gamma are called direction cosines of A vector. Now, from the direction cosines, we can write like this: cos square alpha plus cos square beta plus cos square gamma is equal to 1. This can be proved, but the derivation is not required. Therefore, here you have to remember cos square alpha plus cos square beta plus cos square gamma equal to 1, where cos beta, cos alpha, cos beta and cos gamma are the direction cosines of A vector.